Grade 9s, how are you guys today? Welcome back to yet another lesson in physical science. Today this is lesson number 4 in our series of videos. Today we are going to be looking at the topic alkalis, alkaline substances, alkalis or bases. I am, as always, your teacher, Marshall A.C. Candiado. Right, so in the previous lesson, what did we look at? In the previous lesson, we looked at the concept of acids, right? We looked at the concept of acids. We were able to define the term acid. We were able also to talk about the composition of the acids, to say if we have our strong acid, and let's think of hydrochloric acid, we were able to break down the hydrochloric acid into its constituent parts. Right, that's beautiful, right? We were able to break it into its constituent parts. We were also able to do the same for sulfuric acid. We were able to do the same even for carbonic acid, for nitric acid. We did it for all those acids, right? So now we know the composition of chemicals of acids. Then we also know how they would test for them in terms of using either litmus paper or using pH paper. We now understand that stuff. We also looked at, the first thing we actually looked at was everyday household acids, right? So if you're in the house, how are you able to say, okay, is this substance an acid? Does the substance is it actually acidic? And we looked at examples of acids in everyday life. Right, but now let us move on to our topic for today. Right, so for today we are looking at the topic alkalis. Right, the topic alkalis, bases, alkalis, bases. And what are the objectives for today's lesson? So for today's lesson, we should be able, again now, since we are now looking at bases and we're no longer looking at acids, we should again be able to identify everyday or common sources of bases in household goods, household items. If we are looking at household items, we'd say which ones are actually basic, right? So by the end of this lesson, we would have been able to have identified some common. If you go to Celestino's house, if you go to Elizabeth's house, if you go to Martha's house, if you go to Petrus's house, we'll just find these common acids being there. Yes, even if we come to your house, Amu, as well. Yes, Amu, if we come to your house as well, we will also find these basic substances that contain bases in them. What are our objectives? That was the first one. Right, what are we also going to look at? So we are also going to be able, by the end of this lesson, to describe the chemical composition, the properties, but first we'll have to describe the chemical composition of these bases, right? Same way we did for the acids. Then I would want us to describe the properties, right? We should be able to describe the properties of these bases. Then I will also want us to look at the difference between, we have what we call strong acids, strong bases, and we have what we call weak bases. We have weak bases and we have strong bases. The same way in the lesson for acids, we looked at strong acids and weak acids. That is the same thing that we're going to do here. We should be able to differentiate between strong bases and weak bases. Okay, it's going to be great. Right, so you guys look at these objectives again, and then I'll catch you just now. Okay, welcome back, guys. So I hope you have had a chance to look at the objectives of the lesson, and I hope that you've also been able to just try and think of the common basic substances that have basic substances in them, bases, alkalis. Which substances in the house do you think have bases in them? So here I have written some of them for you. I think in your house, Loide Shilongo, Loide usually sit there, but then today you're not here. Right, so I hope where you're watching from, you were able to think to yourself, okay, if those substances, remember in the last lesson we said Coca-Cola was acidic, we said citrus fruits were acidic. I hope today you were able to think, okay, so now what could be the opposite of these ones? Which ones could be basic? So I wrote some of them there on the board, but before I go to those ones, we would also want to be able to just say the definition or a way of trying to define the term base or alkaline. So a basic substance is a substance that has a pH of 8 or more on the pH scale. So if you go onto the pH scale and a substance has a pH of 8 or more on the pH scale, that's 8, 9, 10, 11, 12, 13, 14, you can't get to 15, 16 because the pH scale only ends at 14. Right, so if a substance has a pH of more than 8, then that substance is definitely an alkaline substance. It is definitely a basic substance. Right, so now let us look at some of the common household items that actually are basic in nature. Right, so I wrote some of them there on the board for you. The first one that is there that I can see, we have bleach. Right, we have bleach. If you think of things like Harpic or Domestos, right, we used to use Harpic when you want to wash these white clothes and you really want to whiten them out, right? Then you have what we call a bleach, right? Then you also have what is that? That one, soaps and detergents. Soaps and detergents. Soaps and detergents, again, that's why we say it in every household we have these basic substances, because everyone has soap in their house. Otherwise, we then have to ask, how exactly are you bathing? How are you bathing if you don't have any soap? So if you have soap in your house, that means definitely you have an example. You have a basic example there of a base substance, of something that is alkaline, right? We also have egg white, right? We also have egg white there, egg white. Then we also have blood. Egg white, do you know what egg white is? If you break an egg, right, there is the yolk, and then there is almost like the cytoplasm that surrounds it. That egg white is basically what we refer to as being basic. Okay, so that substance is also basic. Then blood, right? I wouldn't want to say blood as a common household item. I don't expect to get into your house and just find vases of blood or cups of blood, unless of course I won't say vampires. This is on TV. This is live. I won't say vampires, but unless there are vampires in the house. But blood, because we have blood in our bodies, blood is also a basic substance. Blood is also an example of a substance that is basic. Its pH is more than 7, right? 8 going higher. That is another common example of a basic substance. So if I ask you in the test, give me an example of a basic substance, then you just say blood, because you have blood in your body as well, right? So now we would also like to look at the properties, right? We would also like to look at the properties of these basic substances. So I'll give you guys just maybe a couple of minutes for you to look at some of the properties of these basic substances before I go on to explain them myself. Right, welcome back, guys. So I hope you were able to look at the properties of bases, right? I have tried to just write some of them there for you to try and explain these properties of strong bases. So it says on the board, strong bases are caustic, right? Strong bases are caustic. Remember the word corrosive? Then we have the word caustic. This is also, it means that they can burn and damage the skin. That is why I underlined the word burn and damage your skin, right? In the previous lessons notes and even in these notes, I have indicated clearly that when we're entering the lab, that is why we always have to put on our lab coat, we have to put on our latex gloves, we have to put on our goggles, we have to put on leather covered shoes, right? So that in the event that these strong acids or strong bases were to spill, right, they would go onto our acid resistant lab coats, and then they wouldn't go onto our skin because they would damage your lovely skin, right? And we wouldn't want that. So safety precaution, if you remember first thing when you're in grade 8, lab rules. You must always wear your goggles, you must wear your lab coat, you must wear your shoes, you must wear your latex gloves. You must remember that when you're entering a lab, right? So strong bases are caustic, which means that they can burn and they can damage your skin. Right, which are some of these examples of, then you'd also talk about then the pH. We already said that their pH is 8 and above as a property. We will also talk about their taste, right? They have a bitter taste. We wouldn't advise you to taste them. Like if we were in the lab, I wouldn't even want to see any of you touching any of the sodium hydroxide or magnesium hydroxide and saying I want to taste it so as to determine the properties. But it is bitter to the taste. Right, if you put it to the tongue, it is bitter. So you don't want to taste it because again, it will also damage your tongue. Just imagine if something can damage your skin. What about the tongue? Even worse. Right, so it is bitter to the taste. Then, like we said, they are caustic, which means they can damage your skin. Right, so I have put on the board as well 2 strong bases that are there. You can see we have the sodium hydroxide, NaOH, and then we have also the magnesium hydroxide, MgOH2. Right, those are just 2 examples of strong bases that I put on the board. Right, so I would want you guys to know that, okay, so with these strong bases, right, with these strong bases, remember the same way we did for the acids, they are also able to, they also break down. When we say we have a strong base is a substance which is able to dissociate also completely to form the metal, the Na, right, the metal cation and the hydroxyl ion. So if something dissociates completely and it gives us the corresponding cation, which is usually a metal, and then the hydroxyl anion, then we will know that, okay, this is a strong base. This is a strong base. So I'll give you guys just a small task where I need you guys to write down the dissociation of, let's take magnesium hydroxide, right? Magnesium hydroxide, break it down and write the products that will be formed if magnesium hydroxide was to decompose or to deionize or to dissociate in water, right? Please write it down. Write down the one for sodium hydroxide and the one for magnesium hydroxide. Okay, so now you guys have managed to write down the formula of your sodium hydroxide, and you have been able to break it down into its constituent parts, right? The metal and the hydroxyl, right? The metal cation and the hydroxyl anion. I hope you were able to do that by yourself, okay? And to clearly understand what is going on. So when we have the sodium, right? We have the sodium that we're having here, right? This is sodium Na, hydroxide, the OH part. So when they break down, remember sodium is still coming, it's the same sodium that we dealt with throughout, the same sodium that you find in group 1 of your periodic table, right? So if it is the same sodium that you find in the group 1 of your periodic table, it means its cation surely must be Na+, right? Surely it has to be Na+. And then this hydroxyl, a combination of oxygen and hydrogen. 1 oxygen atom, 1 hydrogen atom. That is a hydroxyl ion, right? So if we look at the hydroxyl ion, it has OH minus. So that is the composition of that base, sodium hydroxide, and it breaks down into Na plus and OH minus. I will be waiting for questions. Please, I will be waiting for questions. In Dailikana, I will be waiting for questions from you, especially. I'll be waiting for questions from you, my daughter, and I'll be waiting for questions from you if it's you, Ndapandula, Daniel, all of you guys, right? I need questions from you guys. I talked about you also, Waunja. You guys haven't been participating, and I'm sorry to expose you like this, but you guys have to participate. Please participate in the lessons, right? So sodium hydroxide, then magnesium hydroxide also breaks down to give us Mg2+, and the hydroxyl ion again, right? So this part, again, we go back to the issue of how, you see, the magnesium 2+ and the hydroxyl ion, think of it this way. This is effectively a decomposition reaction where they have broken down to give us these ones. If we were to have to synthesize them and we were to combine them, Mg2+ and OH minus. Remember how we write our chemical formulas. This 2 plus would go there, right? This negative would come here, and the product that will be formed would be again MgOH2. So when we break it down, that's why it gives us this, right? Which is why we always say, let us always understand the different topics that we deal with, because there is an interrelation, my kids. There's an interrelation between all of the topics that we've done from grade 8 up to the time when we finish grade 12. I will keep on referring to say, do you remember what we talked about when we were in grade 9? And then you'll be like, no, this is science, this is chemistry. Please let us pay attention. Right, so we will also look at, in this lesson, indicators, right? Let us look at the indicators that we then use to determine whether a substance is a base or an acid. No, actually a base, strong base or weak base, yeah. Right, so I hope you guys were able to look at the indicators that you use when you are testing to see if a substance is a base. Right, so in the previous lesson, remember we talked about red litmus paper and we talked about blue litmus paper. So if you're able to look there, I also wrote on the board, right? I also wrote on the board the same information to say, if you observe, where is this? There. Blue litmus paper remains blue in the presence of a base. Blue litmus paper remains blue in the presence of a base. So if you have blue litmus paper and you dip it into an unknown substance, remember we are testing unknown substances here, right? You're just given a liquid, you don't know whether it's acidic or it's basic. So the moment you take your blue litmus paper and you dip it into this unknown substance, remember its original color is what? Its original color is blue. Yes, thank you. Its original color is blue. Then if you dip it into this unknown substance and it remains blue, therefore you would know that that substance is actually a base. That is a positive result if you're looking for a base, right? Now, what if you were having red litmus paper? If you were having red litmus paper, okay, its original color it's a little strip of paper. I showed it to you in the video. I've put the same video in attached it to this same lesson again, right? So that strip red litmus paper, when you just dip it into a basic substance, it changes from red to blue, right? So whenever you have a substance that is a base, the litmus paper, the final color will always be blue. The final color will always be blue, right? So red litmus paper changes to blue in the presence of a base. Then we also wrote about the pH scale, and effectively how it's saying on the pH scale you have any substance with a pH greater than 7, right? Any substance with a pH greater than 7. So if you take your pH paper, you dip it into the substance, right? You take a pH paper, then the pH paper then gets different colors. Please recall this. The pH paper, right, has different colors. Your job is to then take the pH paper with its color is now blue, if it's now green, whichever color it has produced, and then you put it against the pH scale, right? You put it against the pH scale. I've put the pH scale and it is in color, right? Again, also on your document that you're having, it is in color, so that you can be able just to identify, to say, okay, to be able to relate the different colors that are associated with different pHs, right? So if you are using the pH scale and you take your pH paper and you place it on the pH scale, I hope you'll be able to rewind that part. I think I spoke a bit fast. You take the pH paper, it has given you maybe the color, whichever color it has given you, you put it against the pH scale. The pH paper always moves hand in hand with the pH scale. pH paper, pH scale. pH paper, pH scale, because it's only from the pH scale where you can tell what the color on the pH paper is saying, right? So if the pH is greater than 8 on your pH scale, then it's definitely a base, right? If it's greater than 7, 8, 9, 10, 11, 12, 13, 14, these are bases. Right, but then we will then also want to look at the difference in the form of, when we say differentiate between strong bases and weak bases. Differentiate between strong bases and weak bases. Which ones do you think are the strong bases if you were on the pH scale? What is the number? What do you think is the number that will be associated with the strong bases? What is the number do you think will be associated with the weak bases? Just think. Allow your brain to think. Right. So the weak bases, right, if you find a base with a pH from 8, 9, 10, right, those are weak bases. 8, 9, 10, 11 effectively. But then when you have those from 11, 12, 13, 14, those are extremely strong bases, right? Those are very strong bases. And they are the ones which we are saying would probably be caustic, right, if they were to be poured onto your skin, and also depending on something that we call molarity, right? The molar, is it 2 molar sodium hydroxide, is it 3 molar sodium hydroxide, or is it just 0.01 molar sodium hydroxide? I'm just throwing in those numbers just to show you that we still have a long way to go on this journey of chemistry. But for now, just know that if you have a strong base, then that strong base will probably burn your skin, right? It will probably damage your skin if you were to pour it onto your skin, right? Either by mistake or intentionally. The base doesn't know. It doesn't know. It will just burn. Same way fire, whether you put your hand intentionally on a plate on a stove or hot plate, the hot plate doesn't care if you did it intentionally or unintentionally. It will still burn you. That's not its problem, right? So we have basically covered all of the objectives, right? So, but before we do that, let's just look at some of these strong bases. Give me examples, please, of strong bases and weak bases. Okay, so I hope you guys were able to write some of the weak bases that you guys know and some of the strong bases. So I have just put in there that weak bases are basically bases with a pH of 8 to 10, right? pH of 8 to 10, those are weak bases. And we have the example there of saliva, right? I have the example of saliva, salivary amylase, the saliva in our mouths. That is also an example of a weak base. The next one is soap. Then the final one is lime water. You remember lime water? The one which we use when we're testing for the presence of carbon dioxide. That one, that is also an example of a weak base. But observe how the pH is basically pH 8 to 10. pH 8 to 10, that is the pH of weak bases. Right, so if we look now at strong bases have a pH of 11 to 14. 11 to 14, and then we look at some of the examples being sodium hydroxide, ammonia. Ammonia is also a base. Then the final one there being potassium hydroxide. So if you look at them closely, you'll find that those ones just are basic ones. Saliva in your mouth, right? That's why it's not burning our tongue, because it's a weak base, which is why it's not caustic. Right, so we now know our examples of our weak bases and of our strong bases. So we'll be in a position to differentiate. If we were to be asked to say, give us examples of weak bases, give us examples of strong bases, you are now able to do that. Right, so quickly, I put something there on the concept of neutralization in your notes, because that is what we're going to be looking at in the next lesson. Right, so in the next lesson, we'll look at the concept of neutralization, where this is basically the combination of a strong acid and a strong base, an acid and a base, right? Acid and a base neutralizes to give you salt, something else, right? So you guys will look at that, you'll read up in advance, so that when we come into the lesson, that will be lesson number 5. Lesson number 5. This stuff is moving, it's going really well. So you guys should really take this seriously. And like I said in the previous lesson, and I say it again in this lesson, always allow yourself to believe that you can understand all of these things that we're talking about here. Just tell yourself, when you wake up in the morning, say, yeah, definitely, I've got this, I'm understanding this physical science. So objectives covered, you can read them again by yourself. Go over the video again if you want to go over the video, right? Take your time to study, take your time to read. Again, free your imagination. Imagination is everything. As always, guys, you have been great. Thank you. Marshall A.C. Candiado.